Welcome, ladies and gentlemen. I am going to do a brief review about finding slope. Slope is denoted in many ways. One of the few more common ways is to talk about rise over run, or the difference of the y's divided by the differences of the x's. And here's our function. Here's our handy dandy formula here. This m equals, this here is our function that says our slope, which is m, is equal to the y2 minus y1 over x2 minus x1. And so we need 2 points to be able to calculate the slope of the line if it's not given to us. And once we have those 2 points, we pick one of them to be 0.1 and the other to be 0.2. Does not matter which way we do it. Either one can be 0.1, either one can be 0.2, but once you pick, you have to keep them together so that the corresponding x's and y's can be put into the formula. So once you've picked 0.2, right, you're going to put your y value for 0.2 here and your x value for 0.2 here. And hopefully this is making sense and just kind of a little brief refresher. If you have more questions on this, definitely get in touch with me. So a couple things I wanted to continue to talk about. I've got a couple slides here that I'd like to see. Hopefully it will wake up. Okay, here we go. We want to talk about when lines are parallel. And lines are parallel when they have the same slope but different y-intercepts. Keep in mind that if they have the same y-intercept, that is the same line. It's not parallel to the line, it's the same line. So if we have a case where we have our first line is y equals x, then our second line could be y equals x plus 3. So they both have a slope of positive 1. Remember, if I have an x, it's the same as saying I have 1x. Same way I have $1. We know it's $1. They both have a slope that's positive 1, and we do not have the same y-intercept. So these two lines are parallel to one another. All right, so parallel lines. The other thing I want to point out is parallel lines, we have the symbol in math that's like two straight up and down lines right next to each other that's indicating parallel. And the word parallel has those two in there, those two lines kind of hiding in the word parallel. So it's pretty easy to keep track of which one is parallel and which one's perpendicular. All right. So similarly, we are going to take a look at when lines are perpendicular. And they're perpendicular when the slopes are opposite inverses. So if you want to pause and think, and back in, whatever class you took way back when, that talked about opposites, it means the opposite sign. All right, so it's the same number, but it's the opposite sign. The inverse is a fraction that's been flipped on its head. It's a reciprocal fraction. Another way to test this is to take a look at two of the slopes and you multiply them together, right? So you would have a solution of -1. If that's the case, those two lines are perpendicular. So I give another example. An example would be that if y equals 3x and I have another line where y equals -1/3 x plus 4, when we multiply the 3 and the -1/3 together, we wind up with a -3/3, which reduces to -1. So those two lines are going to be perpendicular to each other. Perpendicular means that they meet and they are 90 degrees on where they meet. The other thing you might want to know, and this is kind of an obtuse one, but I'm going to mention it, but orthogonal is the same as perpendicular. I don't know how many people have ever heard the word even, but occasionally you will bump into orthogonal, and all that means is perpendicular. All right, and then I have like one other thing to do with slope that I want to be sure to cover. So our other significant slopes. Horizontal lines have a slope of 0 since the line does not go up or down. Remember, horizontal, we're just going straight across, right? And there's no rise, there's nothing to go up, so the slope is 0. So our vertical lines are considered to be undefined. Remember, the x values are the same, which means that we can subtract, and if we were to subtract, they would go to 0. We cannot have a 0 in the denominator of a fraction, so the slope is undefined in that case. All right, so hopefully this has been a helpful little review of slope and some of the specific things about slope that are kind of cool or kind of important. And if you have questions, certainly contact me or leave messages in the comments section, and I can follow up with you.